effective stress is 0. Let me tell you, effective stress is 0. So I can write now gamma sat into, anybody ready to tell me now? Gamma sat into L minus gamma W into H plus L, which is equal to, this is sigma minus U. U, you see, you are calculating pore water pressure. That's why you are multiplying with unit weight of water. You are calculating soil pressure. That's why you are multiplying with gamma of soil. Here you see, soil is saturated. As I shown you, the soil sample is saturated. So that's why here you see, one can see now this is the upward flow. Very easy to draw. And this is the upward direction. What is this? Anybody ready to tell me? What is this? L. What is this? ఎవరైనా చెప్తారండి?
H.
H. That's absolutely correct. Now one can see now what is going to be happen now. Gamma sat L minus gamma WL minus gamma W into H is 0. Eventually becomes 0. I'm not saying it was not happen emotionally. Eventually, as the head is increasing, particles loses their contact. The structure built on the soil, what type of soil, saturated silty sand, is going to be sink. This is what we have seen with our eyes. Now let us proceed now. What is going to be happen now? Gamma sat minus gamma W. L is common, which is equal to gamma W into H. Now what I'm trying to ask you, gamma sat minus gamma W is gamma prime. If you are not happy, SUB is submerged. L is equal to gamma W into H. Let me tell you now. H by L is equal to gamma prime by gamma W. What is H by L? I. I means, anybody ready to tell me? Hydraulic gradient. Now this is the situation is where critical, that's why we are calling critical hydraulic gradient. But see, many times I'm skipping how we are getting G minus 1 by 1 plus E. Now I will explain you, because this is very important question for us. Now we cannot hide anything. So let us proceed now without further delay. Are you ready now? What we are doing now is, let me tell you, gamma prime. What do you mean by gamma prime? Gamma sat minus gamma W. So somebody is very much interested to know how to calculate gamma sat. How to calculate gamma sat? So this is a good question. So I can tell you, we have one formula. We are repeatedly discussing, even in sessional 1, unit 1 also. G plus SE into G plus SE into gamma W by 1 plus. Anybody is ready to tell me? E. Now if SR is equal to 1, what is gamma now? Gamma becomes gamma saturated, G plus E into gamma W by 1 plus E. Now let us proceed without further ado. I want to calculate gamma prime. I'm not happy with the gamma. Even I am not happy with gamma saturated. Now we are at the right discussion. We want to calculate gamma prime. This we are trying to call gamma submerged. So some books write gamma sub, some books write gamma prime. You can use whatever the symbol you want to use. Now gamma prime is equal to gamma sat minus gamma W. So this is very easy to understand now. Anybody ready to help me now? So what I'm doing now? G plus E into gamma W by 1 plus E minus 1. So what is the answer now? Here you see gamma W minus gamma W. What is common now? What is common?
Gamma W.
So now what is happening? The magic here, G plus E minus 1 plus E by 1 plus E. So what is happening now? E becomes cancel, G minus 1 gamma W by 1 plus E. Very easy to understand how to calculate gamma prime. But here we see we are not deviating. We want gamma prime by gamma W. Gamma prime by gamma W. That's the story of what happened to gamma W. Gamma W by gamma W. Both are cancelled. So I am getting an expression, very simple expression to compute critical hydraulic gradient, which is undoubtedly ICR is equal to G minus 1 by 1 plus 1 plus 1 plus E. So now let us proceed now. We have a question. So what happening now? The head is in picture. Now gamma W into H plus L. It's not just L because you are increasing the head. You are increasing the head. Now the head is also acting as a pore water pressure. So don't write just gamma W into L. Now gamma W into H plus L, and it becomes effective stress becomes anybody ready to tell? Becomes effective stress becomes 0. Effective stress becomes 0. So the moment you see the effective stress becomes 0, soil particles loses contact, the structure is going to be sink. This critical phenomena is called fix and condition, and also called sand boiling. This could happen in case of upward flow in saturated silty sands. Saturated silty sand. This phenomena is happening in saturated silty sands. So finally, anybody ready to speak loudly? What is the formula for computing critical hydraulic gradient? So G means strictly speaking GS, specific gravity of solids, minus 1 by 1 plus 1 plus E. So with this, concentrate on this question, calculate the hydraulic gradient. In fact, he wants a critical hydraulic gradient of a soil deposit with specific gravity of solids 2.65 and wide ratio 0.65. So what is your answer now? How to compute the critical hydraulic gradient? If GS is given, E is given. Are you ready now? So please tell me how to compute. Anybody ready to tell? Please help me so that we will move to the next question. So what is the formula to compute critical hydraulic gradient? So without any further delay, I can write ICR is equal to gamma prime by gamma W. Gamma W is going to be cancelled. So finally we are getting GS minus 1 by GS minus 1 by, what is the answer? 1 plus, it is your time now. 1 plus, ఎవరైనా చెప్తారండి? 1 plus E. So this is critical hydraulic gradient. Now GS, what is the GS now? GS is given how much it is? GS is 2.65 minus 1 by 1 plus 0.65. The beauty in the question, we are searching for calculator, but 1.65 by 1.65 is 1. That's the answer. So if you have any doubt, you can